Law of cosines. Sounds a lot like the law of sines, looks very different. Before we jump into it, we're going to throw one more bonus triangle area formula at you. There is actually a formula out there that if you just know the three side lengths of the triangle, that you can figure out what the area of the triangle is. Always pays to think a little bit about the triangle inequality and make sure that the two short sides in the triangle add up to something that's bigger than the long side in the triangle. We'll see that in the example here. We'll verify that. But for now, the formula for the area of triangle ABC, where you first of all have to make this early calculation. You add up the sides of the triangle, so the perimeter, and half of that perimeter is called the semi-perimeter. That's the S that they're using in here. And once you have made that S calculation, then the formula for the area of the triangle will be S times S minus A times S minus B times S minus C. So four things under the square root there. This will give us the area of the triangle. So for example, in a triangle with sides of 30, 26, and 47, we're going to first of all calculate what our semi-perimeter is. So 30 plus 26 plus 47. Of course, I picked something that's going to have a decimal in here. But 5690 looks like half of 103, I believe. 56, 90, 613. Yep. Okay. Half of 103 is what, 51.5. So the area of this triangle is going to be the square root of 51.5 times 51.5 minus 30 times 51.5 minus 26 times 51.5 minus 47. If any of those come up negative, then you probably didn't have a triangle to begin with. Okay. Simplifying some of these, that's going to be what, 51.5 times, that looks like a 21.5 times, let's see, 50 would be 24, 25.5, and 4.5. And we'll just enter that into our calculator exactly that way. And I get approximately 356.45 square units, whatever the units happen to be. All right, let's get into the meat of this thing and talk about the law of cosines. Law of cosines is generally shown in three different forms, but there's a very distinct pattern to the forms. And it doesn't take much looking at to figure out some strategies for memorizing it. So one form would look like a squared, it's a lowercase a, so it's referring to a side, is equal to b squared plus c squared minus 2 times b times c times the cosine of angle A. So it starts with an A, ends with an A, and we got the b and c are mixed up there in the middle. Okay. But this is not a right triangle, so any given side is as important as any other one. So we can also look at this as b squared is a squared plus c squared minus 2 times a times c times the cosine of angle B, because we started with side B. Or we can start with side C and say c squared is a squared plus b squared. Looks very Pythagorean theorem at that point, but it's not a right triangle, so there have to be some adjustments for it not being a right triangle, and that's what this minus 2ab times the cosine of c is. Remember, this is all multiplied together here at the end, so that's one piece. There's kind of three terms, three pieces on the right-hand side. All right, so you can choose to memorize one of these in one form and then just relabel your triangles to match however you want. Here is our first example for finding a missing side in a triangle. We have, this works for side angle side. So that's what we've got going on in this situation. We got the side, the included angle, and the other side. And if I throw some labels on this triangle, I'll just do it like this. That's ABC, which means this is little side C, this is little side A, that's angle B, and this is little side B, which is the one that I'm going to try to find. So the green formula, coincidentally, is the one that I want. Okay. So I'll write B squared is equal to A squared, so that's 7.1 squared, plus C squared, 5.3 squared, minus 2 times 7.1 times 5.3 times the cosine of the 88-degree angle. Okay. I'm going to pause for a second and calculate some of these. So you should take a minute here to check and verify that you get the same number. 7.1 squared is 50.41, 5.3 squared is 28.09. The 2 times 7.1 times 5.3 times the cosine of 88 degrees should give you a 0.4956. If it doesn't, make sure your calculator's in degree mode and not radian mode. That'd be the first thing I'd check if it doesn't come up with that. Now, what I'm going to do here in practice is the b then to get by itself is going to be the square root of all of this stuff, and I will just keep that stuff all in my calculator together and say do the square root of the previous answer. And so when I add those things together, I get this 78.0044 business, which I'm storing on my calculator, and I'm just going to say do the square root of that answer, and I get approximately 8.83. This with just one decimal point in here, the 8.8 is probably close enough. So about 8.8 on that side. It makes sense that it would probably be the biggest side in the triangle with the 88-degree angle there. Now, if I want to go and find these angles, I'm going to go back to the law of sines to find the missing angles. So I'm going to use the sine of the 88 degrees over the 8.8 that I just calculated, which is an approximation, and so these are going to be at best approximate answers. And I'm going to find angle C next. I always want to find the smallest angle if I can. That makes sure that I don't run into the case where the inverse sine is not able to give me the answer that I want. So when I solve this one, it's going to be that C is the inverse sine of 5.3 times the sine of 88 all over 8.8. So when I do that calculation, I get about a 36.9 degree angle for that one. And then I'm just going to use the fact that the three angles of a triangle add up to 180 degrees to figure out what's left over, which ends up being 55.1 degrees for this angle. So I now know all the angles, all the sides, and I have solved that triangle. All right, so that's if you're given side, angle, side, how we would do that. In this one, we are going to take a look at finding the missing angles in this triangle, and all I know is the three sides. So this is clearly a side, side, side situation. I can throw my labels on here. Just like that is fine. And use whatever I want here. Now the inverse cosine has the ability to give me answers that are bigger than 90, so I'm going to go ahead and use it to find angle B on this. And verify, first of all, that 9 plus 15 is bigger than 22, just barely, it's 24. Okay, so this is actually a triangle that exists. So I'm going to go with the 22 squared is equal to 9 squared plus 15 squared minus 2 times 9 times 15 times the cosine of angle B. So that's 22 squared, which is 484, is equal to 81 plus 15 squared is 225. 2 times 9 times 15 is 270, but that 270 isn't really a 270 because it's a 270 times the cosine of what angle B is. So I need to be careful that I'm not just subtracting 270 from something over here. So one more step here. 81 and 225 is like 306 minus 270 times the cosine of angle B. So now I'll subtract 306 from both sides and get 94 plus 84 is 178, maybe. I really should be checking these things on these notes. I'm not just doing it all in my head. Okay, so 178 is equal to negative 270 times the cosine of B. I'm trying to get down to the B. The first thing I'm going to have to do is divide both sides by negative 270. And I'll get cosine B is negative 178 over 270. I'm suspecting that's going to be a decimal number that I would have to round. But my next step here is to use the inverse cosine. So B is going to be the inverse cosine of negative 178 over 270, and I'm going to put it in my calculator just like that. So second cosine negative 178 divided by 270 gives me 131.2 degrees. Like we said, that inverse cosine can find an obtuse angle for us. Inverse sine is not able to do that. But now I'm going to go to my law of sines again and say, all right, sine of this 131.2 over 22 is equal to the sine of C over 9, which is going to give me that sine C is equal to 9 times the sine of 131.2 divided by 22. So C will be the inverse sine of 9 times the sine of 131.2 over 22. And I'll type that into my calculator just like that. So second sine 9 times sine 131.2 divided by 22, close the parentheses on that, and I get 17.9 degrees. Okay, smallest angle in the triangle, it's actually this one, not drawn to scale here. So that is, I'll write it down here, 17.9 degrees. And then I'll do the 180 minus the 131.2 minus the 17.9. And that leaves 30.9 degrees for this angle. And now I know all the angles and all the sides in that triangle. All right, one more problem here. Put a little bit of a story in this. Bryson is on the tee of a straight 574-yard par 5 golf hole. He hits a drive that travels 340 yards but is 15 degrees offline. Okay, how long does his next shot need to be if he wants to hold the next shot? So if he wants a hole in 2 on this par 5, well, what we know is that from where he is to where he wants to be in a straight line was 574 yards. What he actually did was hit it at a 15-degree angle off of that, and it went 340 yards. And so we want to know what's left if he's going to hit that shot. Okay, well, this is side angle side. This is the side that we want to find. We'll call it whatever we want. If we call that A, then this is angle A. And the B and the C don't matter quite so much. But we are going to then use the law of sines to figure out what that is. A squared is equal to 340 squared plus 574 squared minus, on there, minus 2 times 340 times 574 times the cosine of 15 degrees. This time I'm going to enter everything on the right side of that equation. Since there's no variable in it, I'm going to put it just like that into my calculator. 340 squared plus 574 squared minus 2 times 340 times 574 times the cosine of 15. And that is going to give me that A squared is equal to 68055.83148 and some other stuff. That's a long way, but that's not the answer, right? That's A squared, so I need the square root of that. Square root of 68055.83148, etc., which is approximately, I'll use the previous answer feature on my calculator, again, approximately 260.88 feet, or yards, sorry, that he has remaining to the hole. All right, so this law of cosines, again, very different looking than the law of sines, useful for solving types of triangles that wouldn't have worked. The general progression that you want to go through is, if you're trying to solve a triangle, first of all, see if it's a right triangle. If it's a right triangle, you can use sine, cosine, tangent, Pythagorean theorem. Okay? You can always use that the sum of the angles are 180 to fill in missing angles if you know 2 of them. Okay? If none of those work, then you go to the law of sines. Okay? Be careful with it. You know, check it. If you have that side-side angle, then you might have 2 different answers that you have to deal with. Okay? But then after you have tried the law of sines, if you set it up and you don't have enough information in the places that you need to be able to solve for something, then you go to the law of cosines. You should only ever have to use the law of cosines one time on a problem. And then you will have enough information that you can use the law of sines. All right, so that is it for this one.